In this video, we will be solving equations such as these involving double angle identities. Notice that right here I have cosine of 2x, for example. That is a double angle. So I will be using these double angle identities and making the substitutions that I need as I go along. Also, don't forget about these values. I'm going to be assuming that you have these values committed to memory. If you have not memorized the facts on this screen, go ahead and pause the video right now and don't go any further until you have committed these facts to memory. I see cosine of 2x. Now this is very special because there actually are three different formulas for the cosine of 2x or theta or whatever. And here they are. We have three different formulas. So you can pick the one that you need. So the top formula involves cosine and sine. The second formula involves only cosine, and the third formula will give you only sine. So you can choose based on what you want, sine, cosine, or a combo. Okay, now considering that the other side of the equation has sine, and we really want to have all one type of function, then when we do our substitution, we should pick the version of this formula that involves sine. So that way we will have all sines. So that's why I'm going to pick, let me change colors, I'm going to pick this bottom one. I'm going to pick this version right here. Alright, because this is the version that will give me sine. So cosine of 2x is going to equal 1 minus 2 sine squared x. Okay, cosine of 2x is going to equal 1 minus, whoops, I forgot the 2. I almost just wrote 1 minus sine squared, but that would be wrong. 1 minus 2 sine squared x. Okay, I made that substitution using the identity. And now, meanwhile, I bring down the right-hand side. So now I have all sine function. And they all have just x in here. You can't do it if one of them is x and one of them is 2x. It has to be the same variable. So this should be doable. I'm going to get 0 on one side. So I'm going to subtract 1 from both sides, and I'm going to add 2 sine squared x to both sides. Alright, in other words, I'm moving the 1 over to the right hand side, and I'm moving the 2 sine squared to the right hand side. That's going to leave me with 0 over here. Now over here, and now I'm going to put these in descending exponential order. So I'm going to put the 2 sine squared x first, because that's squared. And then I'm going to put plus sine x. I'm going to put this second. And then the constant will be last. So I'll put that minus 1 on the end. I'm hoping this is factorable, so let's give that a shot. I'm betting that it's factorable. 2 sine squared x can only factor as 2 sine x times sine x. Now look at the end, 1. 1 can only factor as 1 times 1. Now inner plus outer must equal the middle. Inner, I have 1 sine x. Outer, I have 2 sine x. I'm trying to get a middle of 1 sine x. That will happen if I have a minus 1 and a positive 2. So that means this will have to be minus and this will have to be plus. Will that give me negative 1? Yes, negative 1 times positive 1 is negative 1. So we factored it. Now we can get our solutions using the zero product property. Let's go ahead and set each of these factors equal to 0. So if I take 2 sine x minus 1 and set that equal to 0, and I will take sine x plus 1 and I will set that equal to 0. Adding 1 to both sides, I have 2 sine x equals 1. Dividing both sides by 2, I have sine x is equal to 1/2. The sine of what angle is 1/2? Well, pi over 6 pops into my head, but remember, that's just giving me the reference angle. The reference angle is pi over 6. And one more time, I'm getting this information from the chart that I memorized. Sine of pi over 6 is 1/2. So the reference angle is pi over 6. So again, check out my diagram. Alright, I'm going to draw a quick diagram of pi over 6's to help you visualize what's happening a little bit better. Okay, these are pi over 6's. Here are the 4 angles that have a reference angle of pi over 6. 2 of these will give me a positive 1/2, and 2 of these will give me a negative 1/2. Sine is a y value on the unit circle, so it is positive above the x-axis and negative below. For this particular problem, we want positive 1/2. So that's why I'm going to have these 2 angles as my solutions. So those angles are, the first one is pi over 6, and the second one is 5 pi over 6. Okay, so I have these 2 solutions so far. Okay, now what about the other little equation over here? Subtracting 1 from both sides, I get sine x is equal to negative 1. Well, okay, the sine of what angle is negative 1? Well, for that we need to think about our quadrantal angles. This is 1, 0, and 0, 1, and negative 1, 0, and 0, negative 1. Sine is the y value on the unit circle, so we're looking for the y value to equal negative 1. And this is the only angle where the y value is negative 1. So that's why, in addition to the 2 solutions I already have, this angle is another solution. So that is x equals 3 pi over 2. So these are the 3 solutions to problem number 6. Problem number 7. Looks like we're going to get to use our double angle formula again. Now remember, cosine has 3 different versions of the double angle identity. Alright, the first version involves cosine and sine. The second version gives you only cosine, and the third version gives you only sine. So you can pick the one that you need. Now, considering that the other side of the equation has cosine, then I recommend picking the version that will give you cosine. So for this problem, I'm going to pick the middle version. Okay, because it will give us cosine. So let's see, cosine of 2x will equal 2 cosine squared minus 1. Alright, let's do that substitution. So cosine 2x will give us 2 cosine squared x minus 1. And that will equal cosine x. I just brought that down. So now I have all cosine, and they all have the same type of variable. They all just have x. Before, this one has 2x, whereas this one has a variable of just a regular x. You can't solve an equation that way. They have to have the same type of variable. So, what's good? Let's get 0 on one side. So I'm going to subtract cosine x. So that's going to give me 2 cosine squared x. Now as I subtract this, it's going to go in the middle between these two. So here comes my cosine x that I just subtracted. Now here comes the minus 1 that I'm just bringing down, and all that will equal 0. Now this looks like something I can factor. 2 cosine squared will only factor as 2 cosine x times cosine x. 1 can only factor as 1 times 1. Inner plus outer must equal middle. Inner, I have 1 cosine x. Outer, I have 2 cosine x. I'm trying to get a middle of negative 1. That will happen if I have a positive 1 and a negative 2. So that means this has to be positive and this has to be negative. Will I get a negative 1 at the end? Yes, positive 1 times negative 1 is negative 1. So this is how you factor it. Now I can use the zero product property to get solutions by setting each factor equal to 0. So 2, okay, I messed that up. Let me try that again. 2 cosine x plus 1 is equal to 0, and cosine x minus 1 is equal to 0. Over here, subtracting 1 from both sides will give me 2 cosine x is equal to negative 1. Dividing by 2 will give me cosine x is equal to negative 1/2. Okay, the cosine of what angle is equal to negative 1/2? Look, forget the negative for a minute. The cosine of what angle is 1/2? Okay, I'm talking about the reference angle. The reference angle is pi over 3. Alright, sweetie. Because I'm looking at my facts, things that I know. Cosine of pi over 3 is 1/2. Alright, that's so my reference angle is pi over 3. Now look at this diagram to help you focus your mind. Here's a diagram of pi over 3's. So these 4 angles have a reference angle of pi over 3. The cosine of any of these will be some kind of 1/2. But these two will be positive 1/2, and these two will be negative 1/2, because cosine is an x value on the unit circle. X values are positive to the right and negative to the left. In this particular case, we want negative 1/2. So that's why we're going to choose these 2 angles for our solutions. These 2 angles are the solutions. So what are they called? So I have x is equal to, this is 2 pi over 3, and this one is 4 pi over 3. Okay, so I have these 2 solutions so far. Now, what about this other one? Adding 1 to both sides, I get cosine x is equal to 1. Alright, so cosine of what angle is equal to 1? Well, we're talking about quadrantal angles now. Okay, this is 1 comma 0 and 0 comma 1 and negative 1 comma 0 and 0 comma negative 1. Cosine is an x value on the unit circle, so where is the x value equal to 1? Boom! That's it. That's the only angle that has the x value is 1. And that's angle 0. So I'm going to have x equals 0 in addition to the other 2. So these are the three solutions to problem number 7. Okay, problem number 8. Cosine 2x once again. Once again, let me draw your attention to the fact that there are 3 different versions of the cosine 2x formula. And so I need to pick the one that gives me what I want: cosine, sine, or a combo. So in this case, I'm imagining doing the substitution. The rest of the equation, I see I have a sine x. So if I substitute, it would be nice to just have only sine x here. So one way of doing this would be to pick the version of the double angle formula that's going to give me sine. Okay, so maybe I'll go ahead and pick this version of the formula. Alright, I have a feeling that I could solve it also using one of the other versions, but this is the most direct. Let's just keep going with this. So cosine of 2x is equal to 1 minus 2 sine squared x. Okay, so there I've just made this substitution so far. And now I'm just going to bring down the rest of it. So I'm going to bring down the plus sine x that you see right there. So now I have all sine, and the only variable is x instead of x and 2x. So this is good, I guess. The only thing I'm hesitating about is I see that my leading coefficient is negative. Let me write this in the proper order. So right now I have negative 2 sine squared x plus sine x, and then I have this plus 1. Okay, I just moved this over to the end. I don't like to factor when the leading coefficient is negative. So an easy way to solve that when I'm dealing with an equation is I'm allowed to divide both sides of the equation by -1 if I want. So multiplying the left side of the equation by -1 looks like this. Did I say multiplying? I meant dividing. Dividing the right side by -1 looks like this. So basically, I'm allowed to divide everything by -1. It still will be a valid equation. That's just going to change all the signs. So this is going to give me positive 2 sine squared x minus sine x minus 1. 0 is still 0. Alright, I'm much more comfortable factoring this. So let's go ahead and try to factor. 2 sine squared can only factor as 2 sine x times sine x. 1 can only factor as 1 times 1. Inner plus outer must equal middle. Inner, I have 1 sine x. Outer, I have 2 sine x. The middle is -1. So I can get a -1 out of this if I have a positive 1 and a -2. So that means this would be positive and this will be negative. Will that give me -1 at the end? Yes, it will. Positive 1 times -1 is -1. So we have indeed factored correctly. So now let's use the zero product property to get our solutions. Meaning, let's set each of these factors equal to 0 and solve. Okay, let's go. Subtracting 1 from both sides, I'm going to have 2 sine x is equal to -1. Dividing both sides by 2, I'm going to have sine x is equal to -1/2. Adding 1 to both sides, I'm going to have sine x is equal to 1. Okay, the sine of what angle is negative 1/2? Well, forget the negative for a second. The sine of what angle is 1/2? Hopefully you were just thinking pi over 6, alright, which tells you the reference angle, because we know that the sine of pi over 6 is 1/2. Okay, but that's just the reference angle, but I will go ahead and draw the diagram. Okay, the reference angle is pi over 6, so I'm going to draw a pi over 6 diagram. Okay, so here's a diagram of pi over 6's. Now, I have 4 angles that have a reference angle of pi over 6. And here they are. The sine of all of these will be some kind of a 1/2. But these two will be positive 1/2, and these two will be negative 1/2. Sine is a y value, positive up and negative down. For this particular problem, I want negative 1/2. So the solutions will be these two angles right here. So that's why my first two solutions are 7 pi over 6. Okay, that's this angle right here. And 11 pi over 6. Alright, that's this angle right here. So far I have those two solutions. Now, what about this other equation, sine x equals 1? Well, for that one we are talking about quadrantal angles. We're talking about this. Where on the right hand side this is 1 comma 0. Up here I have 0 comma 1. To the left I have negative 1 comma 0. And down here I have 0 comma negative 1. Now sine is the y value on the unit circle. So where is the y value equal to 1? Boom. That's it. That's the only place where the y value is 1. So that's why, in addition to the two solutions I already have written, I'm going to add pi over 2 to the list. So these are the 3 solutions to problem number 8. Alright, here comes another problem involving double angle. Alright, cosine 2x. And again, cosine 2x has 3 different versions of the formula. So you can choose the one you want. The first version gives you cosine and sine. The second version gives you cosine, and the third version gives you sine. So look at the rest of the problem to decide which one you want. Looking at the rest of the problem, I see cosine. So I think we should use the version that gives us cosine. Okay, so let us do the middle version because we will get cosine out of it. Alright, so cosine 2x equals 2 cosine squared x minus 1. Okay, so 2 cosine squared x minus 1. So I've just done the substitution just for this part so far. Now I'm going to bring down the plus cosine x, that's right here, equals 0. Let's rewrite this in the proper order. Basically, I'm going to take this negative 1 and just move it over to the end. So that's going to give me 2 cosine squared x plus cosine x minus 1 equals 0. This looks like the type of thing that would be factorable, so let's give it a shot. 2 cosine squared x can only factor as 2 cosine x times cosine x. 1 can only factor as 1 times 1. Inner plus outer must equal middle. Inner, I have 1 cosine x. Outer, I have 2 cosine x. I'm trying to get a middle of 1 cosine x. That will happen if I have a negative 1 cosine x and a positive 2 cosine x. So that means this would have to be negative and this would have to be positive. Will that give me negative 1? Yes. Negative 1 times positive 1 is negative 1. So we factored it. Now we do the zero product property to find the solutions by setting each factor equal to 0. Adding 1 to both sides, I will have 2 cosine x is equal to 1. Dividing both sides by 2, I will have cosine x is equal to 1/2. Let's go ahead and talk about the solutions that we would get here. Cosine of what angle is 1/2? Well, the first thing that pops into my mind is pi over 3. Now that is the reference angle. It's not just plain the answer, but I know because of facts that I've memorized that cosine of pi over 3 is equal to 1/2. So, diagram. Here's a diagram of pi over 3's. There are 4 angles that have a reference angle of pi over 3. Here, 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 and here. All of these will give me some kind of 1/2, but these two will be positive 1/2, and the cosine of these two will be negative 1/2. For this particular problem, we want positive 1/2, so my solutions will be here and here. So that's why so far I have x equals pi over 3, that's the first one, and 5 pi over 3, that's the second one. 3, 4, yep, okay, so now let's look at this last one over here. Subtracting 1 from both sides, I have cosine x is equal to negative 1. So what about that? Well, we are talking about quadrantal angles now. Okay, and I'm talking about the fact that over here, this is 1, 0. And up here I have 0, 1. Whoops. Over here I have negative 1, 0. And down here I have 0, negative 1. Cosine is an x value. So where is the x value equal to negative 1? Boom! That's it. That's the only place where the x value is equal to negative 1. So that's why, in addition to the angles that I already have, I'm going to add one more, pi. Okay, that's because of this right here. So these are the 3 solutions to problem number 9. Alright, for number 10, once again I have this double angle to deal with. Now remember, when you're talking about cosine 2x, it's a little bit special because there are 3 different versions. One version gives you cosine and sine, one version gives you cosine, and the third version gives you sine. So you can pick and choose which one you want to do based on what you need. I would look at the rest of the problem. In the rest of the problem, I see I have cosine. So I'm going to pick the version of this that gives me cosine. So let me glance at it again. And so it looks like the middle version is the one that we're going to want, because this is the version that will give us cosine. Okay, so cosine 2x is equal to 2 cosine squared x minus 1. Okay, so I'm going to take cosine 2x and I'm going to replace it with 2 cosine squared x minus 1. Now I'm just going to bring down the rest of it. I've got plus 5 cosine x is equal to 2. Now these are out of order, so I'm going to move the negative 1 to the end, so that's going to give me 2 cosine squared x plus 5 cosine x minus 1 is equal to 2. I just moved it over. And now subtracting 2 from both sides, that's going to give me 2 cosine squared x plus 5 cosine x minus 3 is equal to 0. Now this looks like something that I can factor, so let's go ahead and try to factor it. 2 cosine squared x can only factor as 2 cosine x times cosine x. 3 can only factor as 1 times 3. Now it matters whether I put the 3 here and the 1 here or the other way around. So I'm going to have to do a tiny bit of trial and error this time, because at a glance I don't know which one it is. I mean, I can sort of do it in my head, but let me just show you how you figure out where the 3 goes. Trial and error. The key is that inner plus outer must equal middle. If I do it this way, inner I have 3 cosine x. Outer I have 2 cosine x. I'm trying to get a middle of 5 cosine x. That will only happen if both of these are positive. That would mean that both of these would be positive. So this is looking good so far. The only question is, will this give me negative 3? Uh-oh, people. Uh-oh. I'm not getting negative 3. Positive 3 times positive 1 would give me positive 3. So this was so close, but yet it is completely and utterly wrong. So the only thing I can do is try switching them up. So instead I will put the 1 here and the 3 here and check it out again. Inner plus outer must equal middle. Inner, if I do it this way, I have 1 cosine x. Outer, I have 6 cosine x. I'm trying to get a middle of 5 cosine x. That will happen if I have a negative 1 and a positive 6. So that means this would have to be negative and this would have to be positive. Will that give me negative 3? Yes, negative 1 times positive 3 is negative 3, so this is the right way to factor. So now I can go on and use my zero product property and set these factors equal to 0. So I'll have 2 cosine x minus 1 equals 0, and cosine x plus 3 is equal to 0. Okay, adding 1 to both sides, I will get 2 cosine x is equal to 1. Dividing both sides by 2, I will get cosine x is equal to 1/2. Now, the cosine of what is 1/2? I'm hoping that you were just thinking pi over 3. That's going to be my reference angle, is going to be pi over 3. Because we know that the cosine of pi over 3 is 1/2. Now, this is not the answer, it is the reference angle. So what I need to do is think about my diagram. Alright, if the reference angle is pi over 3, then I'm going to draw or picture mentally a diagram of pi over 3's. There are 4 angles that have a reference angle of pi over 3. Here, 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 and here. All of these will give me some type of a 1/2, but the cosine of these two angles will be positive 1/2, and the cosine of these two angles will be negative 1/2, because cosine is an x value on the unit circle, and x values are negative on the left and positive on the right. In this particular case, I want positive 1/2, so my solutions will be here and here. That's why my first two solutions will be x equals pi over 3 and 5 pi over 3. So I've got that so far. Alright, now let's look at the other factor. Subtracting 3 from both sides, I get cosine x is equal to negative 3. So cosine of what angle is going to give me negative 3? I'm hoping that you will recognize quickly that we will get no solutions from this. Wah, wah, no solutions here. Because remember how sine and cosine work. Remember we used to do graphs of these? The graph of the cosine function would go like this. It would go down and up, and it's a periodic function. It just goes down and up forever. But it goes to a high of 1 and a low of negative 1. So there's no angle where the cosine is going to be negative 3, which is like way down here somewhere. So there will be no solutions from this side of the equation. Skirt! But it's okay. We still had the 2 solutions from the left-hand side, so we're still good. So this will be the answer to problem number 10. Alright guys, that's going to do it for this video. I hope it was helpful, and I look forward to seeing you on the next video.